Hello class, welcome to today's lesson in which basically we're going to explore some of the ideas that have not been explored in regards to this second stage. For example, I'm going to talk a little bit about why division over zero, division by or over zero is not possible in mathematics. Okay, we can never divide over zero, but I want you to understand why. And number two, we're going to talk about the problems or the exercises of pages, I believe they were 63 and 64. If I'm wrong, forgive me about that. The ones about the mathematical studies book, mathematical studies, the big book, for the second portfolio, because I never talked about these problems and I want you to have a good idea about how they are solved. Maybe some of you already solved these exercises by some techniques, but I'm going to tell you how they're solved a little bit. Okay, I'm going to give you some examples for these exercises, and I'm going to explain to you why division by zero is not possible. So let's do it. So first of all, why is division over zero not allowed? Let's see. I'm going to start with an example. For example, guys, when we write something like this, 32 over 2, what do we mean exactly? What is this operation about when we divide a number over another and we want a result in here? What does this mean, this problem? Well, basically, you can think of this in the following way. By what number should you multiply 2, or that is 2 times this number, so that you can get 32, right? You're thinking of division in terms of multiplication. It's kind of like a backwards problem. By what number should I go? 2 times such number, let's call it x, 2 times x will give me 32. So we're trying to find this number. You see, it's the reverse. It's kind of like the reverse operation to multiplication. I mean, in fact, it is. So that's why we know that that number x should be 16, right? Why? Because we know that 2 times 16 will give me 32. 2 times 16 gives me 32. Okay? Another example. Let's talk about 15 over 3. 15 over 3, what's going to be the result? Well, the result is whatever number such that 3 times x should give me 15, right? And so we know that that number 3 times 5, that number should be fine, should be 5, so that we get 15. You see, 3 times this number, which we know is 5, produces 15. So that's basically how you think, uh, that's how you can think about division in terms of multiplication. You see, that's how it works. Okay, why am I telling you this? Because by understanding this fact, by understanding that whenever we make a division, number over another number gives me result. Basically, what we're saying is that this number times this result, or the quotient, should give me the dividend, right? You see, 2 times 16 is 32, and the same here. And we should always, when I face a division like so, I should always be able to write a statement in this way. Always. For each division, you can write a statement of this form. Always. Always. And that is the problem with division over zero. For example, what happens if we try to divide the number 8 over 0? Okay? Basically, what I'm trying to look for as the result is some number. I should put some number in here such that when let's call it x, okay? Such that when I multiply 0 times x, don't confuse this x with this x, this means times. So 0 times x should give me 8. 0 times x should give me 8. So what number could this possibly be? this x. What's going to be that number? 0 times x equals 8. Can I come up with any number? Can I put any number here? Is there any possibility such that 0 times this number should produce 8? Clearly that's impossible, right? Because 0 times whatever number, I don't care what number you put here, that's always going to be 0. So it's impossible to solve this problem, guys. It's impossible to find a number x such that 0 times x is going to be equal to 8 or to 2 or to 3 or whatever number I put in here. It doesn't make any difference. 0 times whatever is going to be uh, 0. Okay, so that's why we cannot solve this problem. You see, 8 over 0, it's an unsolvable problem, so to speak. And so in mathematics, we decide that we're not going to allow this type of operation because it's unsolvable. We cannot find any number such that 0 times this number should give me this number in here. Okay, now I need to be straightforward with you. I'm oversimplifying matters a little bit. Okay, this is the general idea of why we don't allow division over 0. Okay, it's just the general idea. The precise mathematical formulation of what I'm telling you is a little harder than this. And maybe some of you are thinking, well, what about this? What about putting 0 right there? Then we can find an answer, right? Because if I put 0 here, 0 times 0 is going to give me 0, right? Okay, and if you thought about that, good for you. But no, we're not going to see this case. I don't want to, remember, I've been telling you this every single time. I don't want to overload you with so much information. This is just a little taste of why division over 0 is not possible. I'm not going to treat that case. Let's just agree on division over 0 is just not possible. It's an undefined operation. You don't say that it's infinite, okay? Don't answer that. A lot of people want to say that any number over 0 is going to be infinite. No, 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 no. 8 over 0 is just undefined. That's what you say. It's undefined. Okay, you don't answer this problem. It cannot be solved. That's what you have to say. The reason why people say this is infinite, it's not really bad, but you're gonna understand that later in maybe fourth semester. Okay, so that's why division over 0 is not possible in mathematics. Okay, next, let's go to the second thing about the exercises from the mathematical studies book. And first, in order to go into over those problems, I want you to understand a mathematical fact, a very simple mathematical fact, very intuitive, which is the following. When you have two numbers multiplying one another, a times b, and if you know that the multiplication or the product of these two numbers is 0, okay, if you know that a times b is 0, but you don't know anything about a or b, there's one thing that you can conclude though, that one of these numbers has to be 0, okay? The conclusion is that at least one is 0. That is your conclusion, okay? Because the only way in which a product can be equal to 0 is by either the first factor or the second factor being equal to 0. So at least one has to be 0, okay? That's a fact that is very easy to understand. And it actually has to do with what I said previously, right? So if we know that a times b is 0, then at least 1 is 0. Well, maybe I should put it a little clearer. At least a or b is 0. At least a 0 or b 0. One of them has to be 0. Perhaps both, right? But at least one of them. And we're going to use this fact, okay? This fact is a very, it's important for you to remember it. It's very simple to understand, so you won't have trouble, because we're going to use this fact in the solution to the exercises. So in the first section, guys, you have the following instructions. Solve for x. and they're gonna give you some equations, 6 equations, and I'm gonna give you the first example. I believe with a couple of these, you're gonna understand how it works. It's very simple. So you have this equation. This trinomial of second degree equals 0. Okay, so how do we solve this equation? Very simply, what you have to do is this. You're gonna factorize the trinomial. Okay, in this case, I can see the factorization right away. That's gonna be the factorization, right? All of this is equal to this. And I continue writing my equation because I still have an equation. I'm just writing the trinomial in a factorized form. That's all I did so far. Okay, perfect. Now, I notice the following. What do we have in here in this equation? We have the multiplication of one number, which is all of this. I'm going to take all of this as a number because it is, right? And times another number. And the product of these two numbers, guys, is being equal to 0. You see? So what do I have here? I have the same as this. I know that the product of two numbers is 0. You see? It has the same mathematical shape. And we knew from before, from a couple of minutes ago, that if I know that a times b is 0, then either a is 0 or b is 0. I can conclude this. If I know this fact, then I can conclude that either a has to be 0 or b has to be 0. And I'm going to use this little fact in my problem. In this case, what is my a, so to speak? This is your a, and this is your b. Okay? So if I know that this number times this number is 0, then that means that either x plus 4 is 0 or x plus 2 is 0. You see? I'm just applying this fact. And once I write down these two independent equations, you see, either x plus 4 equals 0 or x plus 2 equals 0, then I can just solve this equation and this equation independently, one from the other. So then I have that x is going to be equal to minus 4 by solving this equation, or x is going to be equal to minus 2, right? By isolating the x from these two equations. These are very simple isolations. So we have found these two things, x equals minus 4 or x equals minus 2. And what do these numbers mean? These are known as, let me write it here, the solutions to the equation. What equation? The equation that I started with, this equation. If you put any of these two numbers, if you substitute in here any of these two numbers for x, for example, minus 2, let me substitute in there. I'm going to do it over here. You have this. Let me just prove it very quickly. You have this equation. And if you substitute minus 2 in this equation, in place of x, you're going to get minus 2 to the square plus 6 times minus 2 plus 8 equals 0. And is this true? It has to be true. Minus 2 to the square, that's going to be 4, plus this is going to be minus 12, plus 8 equals 0. And then 4 and 8 is going to give me 12. Minus 12 is 0. 0 equals 0. So yes, it checks. Okay? It checks. And also the number minus 4 will check. Any other number that is not minus 2 or minus 4, when you put it in here, you won't get a truthful statement. Okay, you're gonna get something different than this. So this is how it works, guys. Basically, what we're doing is factorize. Let me just give me a few seconds, please. Okay, I'm gonna leave all of this. Basically, it's about factorizing the trinomial, like so. and then this times this equals 0, and then I apply this little fact. Okay, so you're going to use this fact over and over again in these exercises. Let's solve another one. What about, I'm going to jump to section 3. And it's the same instruction, solve for x, so they're going to be very similar problems. And they give you the exercise A goes like this: x squared plus 8x equals minus 16. Okay, so the first thing you do is you bring this term, this constant, to the left side, like so, right? And then you do the same. You're going to factorize this trinomial. This is going to be x plus 4 times x plus 4. I'm not going to explain the factorizations anymore because you should be already somewhat familiar with them. Okay, if you don't believe me, multiply this factor and this factor, and you should be getting this. So the factorization is correct. Now, when I have this, some number times another number being equal to 0, I can use this fact one more time. If a times b is 0, then either a is 0 or b is 0. And I just use this fact. Okay? By the way, pay attention to how I'm reading this arrow in mathematics. I read it as then. Okay? And that's not just arbitrary. That's the way in which you should read this arrow. If a times b equals 0, then either a equals 0 or b equals 0. Then. Okay, so let's do it here. Then I know that x plus 4 equals 0 or x plus 4 equals 0. And then I know that x equals minus 4. Got one of my solutions. Or x equals minus 4. Got the other of my solutions. When I put any of these two numbers, which in this case are equal, that's one possibility. When I put any of these two numbers in my original equation here, it's gonna check. I'm gonna have a true statement. Okay, so I believe that by now you should be getting the idea, right? Let's do D. From that same section, section 3, let's do D. D goes like this: x squared equals 100. So I'm gonna do the same. Bring this term to the other side. There it is. And then factor this expression, this binomial. This is a difference of squares, right? And the factorization will be equal to this, as you know. It's the product of the conjugated terms. I'm sorry, the conjugated binomials. And I do the same thing. Why? Because I observe the same thing. Number times number equals 0. So then I conclude that either the first number is 0 or the other number, which is x plus 10, is going to be 0. And then that implies that x equals 10. After I solve this equation, I got one of my solutions, or x equals minus 10, which is the other of my solutions by solving this equation. And I'm done. I have found that my solutions to this equation are 10 or minus 10. If you input any of these two numbers in here, 10 to the square will be 100, and minus 10 to the square will be 100. So that's how you solve them, guys. These are quite simple. That's the general idea. Now, maybe you're going to get a little confused in section number 5 because you have equations like these ones. Look, I'm going to start with equation E. You're going to see why in a moment. I'm going to start with this equation. It goes 1/3 x squared plus 1/2 x plus 1/6 equals 0. So you may be thinking, well, what do I do in these ones? Just give me a few seconds because okay, I was trying to sneeze. Okay, so you have this equation, and you may be thinking, okay, how can I factorize this trinomial? Because I have fractional coefficients. So I haven't taught you how to do that, and that's what I'm gonna do right now. So what you have when you have this sort of trinomials, you can convert this whole equation into a trinomial with integer coefficients. In this case, the trinomial has fractional coefficients, and we don't want that. We want these things to be integers. So what do? We do the following. You're gonna observe the denominators 2, 3, and 6, 3, 2, and 6, and you're gonna multiply both sides of the equation, the left side and the right side. You're gonna multiply both sides by the least common multiple of 2, 3, and 6. I repeat, the least common multiple of the denominators. In this case, what is the least common multiple between 2, 3, and 6? That's going to be 6, right? Because 6 is multiple of 2, multiple of 3, and of course, it's multiple of itself. So this is the least common multiple. I hope you remember how to get this. If you don't, look it up. So it's going to be 6. Okay, so I multiply both sides of my equation by 6, and it's going to look like this. Remember then, I'm going to multiply all of this by 6, all of it. That's why I wrote it in between parentheses. And all of this by 6. Okay, so what am I going to get? When you multiply 6 times each of these terms, you're going to get the following. 2x squared plus 3x plus 1 equals 0 times 6 is 0. I won't explain why 6 times all of this is this. You do it on your own. And now that we have this, what do you think we can do now? Same thing. Try to factorize this trinomial. Let's do it. It seems as though this is going to be the factorization. 2x times x is this. 1 times 1 is this. And yes, everything checks. So this is my factorization of this trinomial. And once you get the factorization, this number times this number being equal to 0, now you know the rest. I don't have to continue, right? I don't want to bore you. So that's what you do, guys, when you have equations like of this type with fractional coefficients. You're going to multiply both sides by the least common multiple of the denominator in order to get an equivalent equation with integer coefficients. I need you to understand this. This equation that I came up with, this seemingly new equation, is not new. It's the same equation as this. It is the same equation. Okay? It's not a new equation. I mean, it looks different. I get it. But it's the same equation. Okay? Because I got it out of this. Okay. And what about now that I solved E, let's go back to the first one. Same section, section 3, equation A. 0.25 x squared plus 1.75 x equals minus 1.5. So this one looks even more complex, right? Because it's got decimals for coefficients. So let's see. Let's see how we can handle this one. So first, let's bring this one to the left side. It's gonna look like so. There it is. That's the first thing I do. I put all my terms in the left side, and the resulting equation will have a 0 on the right side. Okay, now the first thing I want you to do, well, you're gonna maybe not pause the video right now, but you're gonna look up later. Okay, you have a little homework here. Homework. Look up how to write decimals like this type. How to write decimals as fractions. Okay, and we know that a decimal can be converted into a fraction. For example, if you have 0.5, we know that that's 1/2, right? That's very simple to understand. Or if we have 0.2, we know that this is 1/5. Or 0.1, and we know that that's 1/10, and so on. So every single time you have a decimal like so, it can be converted into a fraction. Okay, so you're gonna look up how to do that with a process, with some sort of method. It's not difficult. It's gonna take you about 5 minutes or something. Okay, so now that you know how to do that, now that you have gone and do this homework, basically what you have to do is convert these coefficients, decimal coefficients, into fractions. Okay, so 0.5, that's gonna be 1/4 x squared, and then 1.75, that's going to be 7/4 x, and this 1.5 can be written as 5 over, no, wait, 3/2, yeah, 3/2. I'm gonna write 3/2. Okay, make sure that what I did is correct. This number is the same as this, 1/4. This number is the same as 7/4, and 1.5 is the same as 3/2. Okay, now what do we do next? The same thing I told you a moment ago. You have coefficients, fractional coefficients, with denominators 4, 4, and 2. The least common multiple of 4 and 2 is clearly 4. So I'm going to multiply both sides by 4. So all of this thing, I'm going to multiply it by 4. There it is. And the 0, I'm going to multiply it by 4. So what am I going to get? I'm going to get x squared. When you multiply this times this, it's going to be x squared. This times all of this, you will get 7x. And this times this, you will get 6. Yes. And you will get a 0 on the other side. So as you can see, we have transformed one equation that looks kind of complex and difficult to work with, okay, into an equivalent equation. It's an equivalent equation, guys. It's not a new equation. It's an equivalent equation that contains only integer coefficients, which is much more manageable. Then what's next? Factorize the trinomial. I'm going to continue with this side. That's going to be x plus 6 times x plus 1. Am I right? Yeah, right. Okay, so you continue with the rest, as I told you. Okay, so that's how you solve these types of problems, guys. I hope that you have understood what I said. If there are questions, you can ask me. And remember, if you don't get like 100% the ideas at this moment, right now, in the first watch, so to speak, rewatch as many times as necessary, rewind the video, etc., until you get it. Okay? Sometimes you have to study things more than once in order to get the idea. And I believe that's it, guys. Um, that's it. We have completed the second stage, and now all that remains to be done is for you to complete it for Wednesday, for tomorrow, so that we can check it in real time in class. Now we're gonna check it among ourselves. So thank you so much, guys, and let's get to work.